This week we're going to review kinematic constraints. Now, kinematic constraints restrict movement in some directions while allowing movement in others, and they're very common in mechanical systems. In fact, there was at least one kinematic constraint in almost all of the homework problems you've done so far. An example of a kinematic constraint commonly found in your homework problems is when you have a rigid rod, and that rigid rod can only move by rotating or pivoting about a point. It can no longer freely move about in 2D space. In fact, each point on the rod will always be a fixed radial distance from that pivot point. And what that means is, for instance, this point P can only ever be at one of these locations defined by this circle here with a radius of r. This means that if you want to describe where any given point on the rod is, all you need to know is the orientation, so the theta value of that rod. Whereas if this rod was allowed to freely move about in space, you would need more variables. You would need to know, for instance, where the position of the center of that rod is, as well as what its orientation is. Another example of a kinematic constraint is when you have, say, a horizontal shaft, as shown here. This block can only move in this direction. The same is true if you had an object that could only, say, slide along a surface. In order to describe the position or location of each of these points, say P1 and P2, all you need to know is where they're located in one direction. In the remaining videos, we're going to cover the following. First, I'll talk about what type of kinematic constraints we're going to consider in the problems that we cover in this course. Second, I'm going to talk about how kinematic constraints influence or can influence the degrees of freedom of our system. Then I'll go over how you have been incorporating kinematic constraints into your kinematic equations and how you should continue to do so. And lastly, I'll talk about why we need to think about kinematic constraints as we move forward in our ultimate goal of this course, which is to derive equations of motion.